We're doing exercise number 8 in the Circuit Analysis Lab book, Kirchhoff's current law and current divider relationships. We're going to need a variable power supply, a protoboard, resistors of 2.2, 3.3, 4.7, 10K, and a 10K potentiometer. Okay, so that's what we're going to do. And first thing we're going to do is hook up two resistors in parallel through our amp meter. So first thing we'll do is hook up our amp meter. So we're removing the positive lead and sending it through our amp meter. And then taking the negative lead of our amp meter and bringing it back. Okay, yep, that's right. I'm only blind. All right, now we're going to put two resistors in parallel, 2.2K and 3.3K. Okay, one more wire going to the negative side. Okay, excellent. We are ready to turn on the ammeter. And in table 8-2, we have some numbers to record. So we're supposed to record the total current, and we'll change the range to a 20 milliamp range, and we have 7.57 milliamps. Okay, now we're supposed to measure the voltage across each of the resistors. We're thinking it's going to be about 10, but we're going to measure it anyway. And so we measure, get that in the right spot, 9.92 volts across R1. And
R2.
Oh, R2, okay, and 9.92 volts across R2. So they're both
R1.
R1, okay. So they're both 9.92 volts. We're then supposed to measure the current through each of them. So voltage divided by current would be that measurement. And then we want to add those currents together to see if we get close to the total current, which we do. All right, so next thing we're going to do is add another resistor to the circuit. And before that, we're going to turn off the power supply. And then we're going to add a 4.7K resistor to the circuit. Okay, so it is added. We're going to turn the power supply back on. And we're going to check out the total current. And the total current is 9.54 milliamps. We're then going to measure the resistance across R1, R2, and R3. We expect them all to be the same.
The resistance or the voltage?
The voltage, yes. The voltage across that's R2, right?
Yeah.
So R2, 9.77 volts. R1, 9.77 volts. R3, 9.77 volts. So who would have thought that was going to be the case? Then we're going to go and calculate the current through each of the resistors, add those currents together to see if that equals total current, and in fact it does. Okay, now we're going to go and take a 10K potentiometer, and we're going to rotate the shaft so it's approximately halfway between the two extremes. Okay, now that's what we're going to do. Alright, so anybody have any good idea how we're going to do that? put on the ohm meter, and maybe with a little bit of luck, we're approximately halfway between already. And yeah, why not? You know, 4.6K out of 10K, that's approximately in the middle. We're going to go and tweak on it a little bit to see if we can make it better than that. Well, that's a little better. Oh, tweak on it a little bit more. Bringing it the other way, and now we see 5.02, 0.03. Yeah, that's perfect. All right, and then we're going to use it to replace the 4.7K resistor. So the 4.7K resistor is going to come out, and we're going to put the variable resistor in a place where we can screw on the screws, and then run a wire over to get it in, run 2 wires over to get it to be in parallel with the, no? Oh yeah, we can do that, yeah, you can do that, yeah. No problem.
I guess I did the hard way.
Long enough. What I would do is I would keep that other guy. Okay, yeah, you can do that.
I can't tell.
Okay. Now, we need one more wire. So what wire do we need? We need the wire that goes from here to, well,
yeah, that makes it a series.
yeah. We need to have that guy go there, that guy go there, and then this guy come over here to negative. All right. Okay, so there we go. We have managed to make the circuit we're supposed to have. And what are we supposed to do next? Apply power to the circuit, measure the total current. All right, so we're going to move over and measure the total current. And we see that we have 9.41 milliamps. And use Kirchhoff's current law to determine the current through R3. So that's a mathematical thing. You'll be able to do that. Use Ohm's law. Calculate the resistance of R3. Notice that we know that the number written down in the lab book is wrong. And then we're supposed to remove the pot, take care in changing its setting, and then measure the value of R3. Okay, well, we already did measure the value of R3. It was 5.04K, so we don't have to do that again. Okay, now we're on step 11. And we're going to construct the circuit shown in the figure below. Okay, so we will do that. We'll disconnect there, disconnect there. So we have power coming into our variable resistor. We have that measuring the amps. Well, it doesn't matter. No, that's fine. We can measure the amps before we go through the resistor. That's fine. And then we have 2 guys in parallel, but I don't think we have a 10K guy in there. We're supposed to have a 4.7 and a 10K guy. And I don't think we have that. Okay, so we're gonna look over here, and we can see that we have 1.45 amps flowing in the circuit. Maybe we can see that. Okay. It says that we're supposed to measure the voltage across each branch. Use the measure voltage and the Ohm's law to calculate the current in each branch and put it in table 8-4. Okay, so that's what we're going to do. We're going to measure the voltage across R1. And on voltage, please. All right, across to R1. And we're measuring 2.57 volts. And then we're going to measure the voltage across R2, which is the 10K resistor, 2.57 volts. And then we have calculations to do. Okay, well that's fine. Now we're going to add another resistor. We're going to add a 3.3K resistor in parallel. So we're going to add a 3.3K resistor in parallel.
I'm doing it.
Okay, and after we do that, adjust the potentiometer so that the total current is 1 milliamp. Okay, so that's what we're going to do next. We're going to adjust the potentiometer, and we're going to watch the milliamp guy, the amp meter. And we're going the wrong way.
We're going the wrong way yet.
Yep, you want to get to 1. All right. And I will put my finger here to help some, or I won't. And cranking on down. .2, 1.15, almost. And we're going to change the scale to a 2 milliamp scale. Our technician doesn't like that idea because now he's got to get closer. Oh, look at that. Oh, is that not, well, you know, it used to be. It was, you know, perfect. Yeah, don't touch anything. Okay, move the camera away from that so we don't see if it changes. Okay, so that's good. Now so we have 1 milliamp going through our amp meter. Measure the voltage across each of the branches. Okay, so we're going to measure the voltage across R1, which is the 4.7K resistor. And we get 1.29 volts. And we measured across R2, which is the 10K resistor, and we get 1.29 volts. Fancy that. And across R3, 1.29 volts. And of course, we're supposed to get that because they are in parallel. We then have calculations to do, and we have more calculations to do, and at that point, we're done with the hardware portion of the lab. There are just questions and problems to do and a simulation to do. So that ends lab number 8.